Afternoon to everybody. I think we'll get started here. Still have a couple people who are joining, but it's starting to slow down. So thanks everybody for joining today. We have a talk that's going to be a little bit more on the technical side. James Harr from Internet2 is going to be talking a little bit about some work that he's been doing with IPv6 recently, in particular, a set of tools that he just called the IPv6 Test Pod. And I believe that James said that you gave a similar talk at one of the nanogs, or is this brand new material that we're all hearing?
I will. It's going to be similar to what a talk I gave at Aaron, and there's going to be some similar content at Nanog in Kansas City. So,
Okay. Well, I'm going to turn it over to you, and you can go through. And if people do have questions, use the chat feature. But otherwise, we'll open up the floor for questions at the end.
all right, awesome. Let me get the chat up so I see it on my. This is where having several screens comes in handy. All right. So I'm James Harr. I am jokingly a recovering network engineer turned software developer at Internet2. I work on a lot of the automation things. Um, one of the things that I have taken a little bit of a liking to is just trying to get IPv6 networks deployed more, and I've been keeping track of it and just looking for ways that we can really sort of move the world forward with that. So in this talk, I'm going to look a little bit at some major events in IPv6. Obviously, I can't cover all of them. Ways that we measure IPv6 adoption, and look at a couple options for IPv6 only networks and transition technologies. And specifically, I'll be looking at ways to get IPv6 only networks to the endpoint. And then talk a little bit about the IPv6 test pod project and ways that I think it could help. I could help move that forward, and then what the current status of the project is. So, um, or IPv6. I mean, I just like throwing this up there. I think a lot of people already know this, but it's not a new standard. Well, it's not a new draft standard anyway. It was 1998 was sort of the first draft of IPv6, and through the in 2010 we had a couple of IPv6 launch events for some major cloud providers enabled IPv6 on their main websites, and they were largely non-events. I think they're people discovered things, but I think it's a big credit to all the work that's gone into that made those non-events. In 2015, the Aaron free pool of IPv4 prefixes was depleted, officially meaning you can only get IPv4 addresses from transfers. And finally, in 2017, IPv6 was ratified as a standard, which, it'll come as no surprise. It's oftentimes technologies will be widely deployed without becoming actual standards. And then another major thing in the U.S. specifically is that in December of 2020, the U.S. government released an IPv6 only mandate, setting specific targets for how far along the U.S. government and its departments should be in using IPv6 only networks. And that was sort of it. I don't know what kind of carrot and sticks that mandate includes. I'm interested in hearing that if anybody knows about it. But to me, it's a pretty big signal that the way to go in a lot of cases. And in March, we had a couple of things that I think are fairly important. There's an IETF draft about IPv6 operations. It's actually really useful to look at if you're looking at IPv6 only networks. It details a lot of the problems you might run into, some design compromises you might run into. And then another thing that happened in March is that Microsoft actually plans to expand CLAT support. And I'll talk a little bit more about that later. But kind of in a timeline, like we've been working on IPv6 for a long time. And we're kind of to the point of, well, why aren't we there? So one of the things that I have opinions on is the way we measure IPv6 adoption. And there are a lot of different ways to do this. Um, you know, Podaroo.net has a lot of good resources on measuring the number of prefixes that organizations advertise, and I think it's Jeff Huston has a lot of good research on the topic, looking at, here's an organization, does it have both IPv4 and IPv6 advertisements? What are the comparison between the two? It's a lot of really interesting information in there. The thing that I actually really like, though, is looking at the IPv6, like the amount of traffic that's going over IPv6, because I think that's actually a much better indicator. That's a much better goal to look at, because if you look at the number of prefix advertised, it makes everybody look pretty good, but then you look at the traffic on the wire, and it's not as good as I think we could make it. It's continually improving, and I think we've seen a pretty good continuous increase in IPv6 traffic. But to me, this is sort of the key. For me, this is the key indicator of like, how far along are we? So that's the one I tend to focus on myself. So when we measure IPv6 deployments at Internet2, we have a tool, Deepfield, that looks at traffic from different origin ASs, and this specific query is looking at number traffic to and from specific origin ASs, and the amount of traffic that's v4 and the amount of traffic is v6. And one of the things that we see is that there are quite a few networks out there that advertise v6 traffic and might have a trickle of advertise v6 prefixes, might have a trickle of traffic on it, but you don't see a whole lot of actual usage on it. And when a network does actually put its end user networks on v6, it gets used pretty widely. As soon as you put v6 on client networks, you'll see a jump from anywhere between 30 to 50% in some cases of your traffic will turn v6 almost instantly just by putting clients on there. There's another percentage that's some research traffic. There's some that's services that are v4 only and things like that. But I think in the research and education community, I think my expectation when I first started working at Internet2 is that we'd be much further along, and we're actually not. We're kind of lagging behind the average here, and I think we could very easily kind of catch back up and sort of advance towards v6 networks. So previously on the slide, we were talking about v4 and v6 dual stack networks, but I think there's actually, when I was doing some experimentation at home, I think there's actually a decent argument to be made that v6 only networks might be possible, and they might actually start to be, that we're getting close to them being able to like just run a v6 only network without having to run dual stack. And I think there's a lot of operational benefits to that. And so I think it's worth starting to make those advancements. So why do v6 only? Well, keep in mind that dual stack's not the end game. And I think it's bears repeating. I think there's some people that already know this, but we're not looking to run two protocols. we're looking to advance to the next one and then get rid of the old one eventually. It's not going to happen for a long time, but the end goal is to run IPv6 only. And it's operationally simpler to run a v6 only network than a v4 if you can do it, because you're not having to run. It's operationally more simple to run one protocol than two. Let me put it that way. Because you're not having to basically manage two networks and figure out what traffic's going over which protocol. I think there's also fewer hidden issues with things like happy eyeballs. If there's a problem with the network, it's just going to break and you got to deal with it. When you're deploying v6 widely, like Google, maybe you don't want that. But if you're deploying it as an enterprise, you might be able to find the issue and deal with it more quickly if you aren't dealing with this fallback to IPv4. I also think that the burden on transition appliances, like if you have a stateful NAT64 box that's translating 6 to 4 to give access to those IPv4 resources. The load on that's going to start higher, but it's going to decrease over time as more networks and more services go v6 only, or at least allow for v6 traffic. And I think that's a versus if you go like if you're looking at IPv4 transition or IPv4 tools like stateful NAT services, the burden on those things is going to increase over time. So what sort of technologies can you use to build an IPv6 only network? Well, obviously you're going to have IPv4 at the internet edge, and you might even have to have it closer to your core. But you might actually be able to get IPv6 only all the way out to your end device, and that's the part that makes it that kind of gets me excited about this and made me realize that this is something that could actually be done. It's a combination of technologies, and the big three though that sort of that I think make it possible are NAT64, DNS64, and 464 XLAT. And there's some other supporting technologies like DHCP option 108, which basically says if you support IPv6 on your host operating system and you support DHCP option 108, I believe that's a turn off IPv4. Like it's a DHCP, it's an DHCP option to say don't use this protocol. There's also a thing called Pref64, which we'll take a look at, which is a way to communicate a network prefix for doing a 6 to 4 translation. So starting at the first part, we're going to look at NAT64. I think a lot of people here are familiar, but I'm going to run through it anyway. But more or less, you have an IPv6 only client, and you have a DNS resolver that is aware that this client network is IPv6 only, and when a query comes in, for domains, let's say example.com, that only has an A record, what's gonna happen is that DNS64 resolver or that DNS server is going to synthesize a quad A record. That quad A record is going to be in a known prefix, and in the example here, I ended up using a well-known prefix for 6 to 4 translation. Basically what it does is it embeds the IPv4 address inside an IPv6 address, which you can do because there's more bits, and then it sends that back to the client. When the client tries to connect to that address, it gets routed through a NAT64 appliance that has dual stack on the internet facing side and goes to that IPv4 only server. There's a reason, I'll see if I can pause for a bit, but there's a reason you may not want to use that well-known prefix that was brought to my attention about a week ago in the IPv6 call, IPv6 working group call at Internet2. But for the most part, this is a pretty good transition mechanism. It's got a few holes though. If you have an IPv6 only client and the software does not look for quad A records at all, or if it binds to an IPv4 socket only, then it's not going to work. It's not going to find. It's going to look for records. It's not going to find an A record, or it's going to find one and not be able to use it. So there is a drawback there. Sorry, that solution made use of two of those technologies, DNS64 and NAT64, in order to sort of build that solution, and it works reasonably well. So the other one is accessing IPv4 using 464 XLAT, and this is one that I wasn't aware of until I started experimenting, and then I found out that this is built into iOS, Android, and Mac OS today, and it pretty much works right out of the box. You almost don't have to configure it. But what 464 XLAT will do is on the client device, it will have what's called a CLAT. And I can't remember what the acronym is, but basically it sets up an IPv4 address on that interface, on that CLAT interface. And it's always 192.0.0.1. And when you try and route traffic over that, what it's going to do is that it will translate that to v6, and it will send it to that known a prefix that it understands. Right now, in this example, I'm using 64FF9B : and then the IPv4 address embedded in the IPv6 address. And then when it sends that traffic over v6, and once it hits a NAT64 appliance or a PLAT, it and you can actually use the same NAT64 appliance that you would normally use in the previous configuration. It'll translate that back to v4. And the thing I was amazed is that this actually just tends to work out of the box, to the point where I didn't know it was working, and it just made use of the existing NAT64 appliance. So that brings up how to configure 464XLAT. There's really two mechanisms that I know of to configure it. There's an RFC for discovering Pref64 announcements in IPv6 router advertisements. It's not supported in all network operating systems, and client operating system support varies. But when I've configured it, Android, iOS, and Mac OS used it out of the box. There's also another RFC, which uses a well-known domain name called IPv4 only.arpa, which, if you do a DNS query on that, it will come back with an IPv4 address and no quad A record. But the client operating system knows that if it gets a quad A record back for that, it knows that DNS64 is being used. And if it sees that DNS64 address, it's going to know the NAT64 prefix. And that's how I was using it on accident, because I had a DNS64 server set up, and why was I able to ping IPv4 address literals? That's one of the magic pieces of this is, even if you have a hard-coded IPv4 address, you can still do it. And you can actually even trace route through it. The trace route doesn't make a whole lot of sense when you're traversing IPv6, because it's weird when you trace route to 1.1.1.1, and there's stuff in the middle that's replying that has a v6 that has the contents of the packet have v6 addresses in there, and I don't think most traceroute knows how to understand that. But it tries, and you can actually still run ping though. But once it makes it to v4 native space, it'll respond just fine. But yeah, this combination actually winds up making a pretty nice story for v6 only networks. So operating system support for 464XLAT right now, iOS, Android, Mac OS all work pretty well. Windows, in its current setup, it only works on LTE interfaces, but all the code is still there. And I see a chat item that's saying that Microsoft is committed to adding 464XLAT support in Q4 of this year for Windows 11, not 10. Thank you, Nick. I did not know actually that it was going to be in Q4 this year. That's really good news. And then on Linux and BSD, these are kind of sort of bring your own tools. I was hoping, at least on Linux, that I would find a distribution that would make it easy to set up, maybe configure 464XLAT, at least the CLAT side of it, but I haven't found any. If that's wrong, I would love to know. And in FreeBSD and OpenBSD, it's supported in PF, but it's, network configuration on those is sort of assemble yourself anyway. So you might, you'll end up configuring it by hand, whereas on most of the other operating systems, the commercial ones, the expectation, I think, is that it's just going to come out of the box ready to work. You won't have to turn it on. You won't have to configure it. It'll just, if it's supported on the network, it will just start working. So there's some typical problems you might run into when you have different environments. Obviously, with an IPv6 only network with no translation mechanisms, if there's not server-side IPv6, it ain't going to work. As you start to go into NAT64 and DNS64, some of those problems go away, but others still exist. And those can exist in some of those problems can exist in dual stack networks. A really interesting one a couple of interesting ones that I've run into where when an application has supported IPv6, but the single sign-on or something in the middle of that sign-on process does not support IPv6. Or once you get logged in, and specifically I'm looking at Outlook. I haven't looked at it recently, but once I got logged in, I was fine, but going through the login process, something failed in the middle. The other thing I've heard people run into, I haven't run into it myself, is when there's a middle box that proxies the TCP connection. And all it's doing is it's a middle box, either there in some mobile networks or sometimes there as a security mechanism that will, I'm connecting to Google and it will sit there and it will accept my connection. This middle box will accept my connection and then establish a TCP connection on the back end to the site I want to get to. And if you have broken IPv6, this will completely break happy eyeballs because the client operating system will say, I'm trying to get to this website. I see the connection. It's good. And then you try and talk over the connection and nothing will happen. But happy eyeballs doesn't deal with that well because it sees the connection was established and it will refuse to fail back to IPv4. So the other one is if you have a hard-coded IPv4 literals and application hard-coded address families, 464 XLAT takes care of that pretty beautifully, honestly. It works well out of the box. There can be problems with it, but it's really kind of it covers even more of the use cases in these examples. So this brings about the IPv6 Test Pod grant. Is granted by Aaron for around $7,000, and the idea, we'll talk about the idea here in a minute. So we're looking at these networks. I spent a lot of time getting these networks set up. I'm a fairly seasoned network engineer. I'm not magical or great at it, but I like to think that I can get things done. And it's non-trivial to set up these environments. You have to understand all the options. You have to get access to IPv6. You have to piece together these technologies, many of which may not be supported by your vendor of choice. And you might get one environment set up, but you may want to test different ones. For example, if you want to do network for dual stack and network for DNS64, NAT64, and then IPv6 only, that's additional setup. And it's really a pain. It took me a while to do this. And if you look at people outside of networking for like enterprise application support or software developers that don't have that networking background, they're just not going to do it. So if we want to help them prepare for an IPv6 only world and develop applications that will work, we need to give them a good test environment to actually run, to set things up and try things out and see what breaks. So like I said, the IPv6 Test Pod is a $7,000 grant. It's targeting client-side testing. The target is making client-side testing easy. What we want to do is buy a bunch of inexpensive devices. The target is less than 150. Well, I think we have that. We just have to make sure that it all works, right? And what we want to do is create a whole bunch of test networks on this device. We want to give access to IPv6, even when access to IPv6 may not exist. And that includes a tunnel termination service. So if you're on an IPv4 only network, you can plug this thing in and it still works. It'll spin up SSIDs for all these test networks. You can connect to it with your phone and see if it works. And the idea is it's just a plug and play. You drop it in, you can do your testing, and really the design is at no cost to participants in this project. You can sign up for it, get one, try it out, hopefully fix some things, and then either with the client application or within your org, or identify where problem spots are. And you don't have to pay anything for it. It's inspired by the RIPE Atlas probes because that's kind of one of the things that they did to get those out there. They're small, inexpensive devices. They can distribute them pretty easily. So the target users for this are going to be application developers that want to test IPv6 only environments. Um, they might be coding for they might be writing code and they might have some bugs that they want to fix. It could be in open source products, it could be in commercial product, it could be in an internal application. Doesn't really matter. Um, it could be for an IT support person that has a slate of applications that they need to support, and they want to get ready for an IPv6 only environment where they have 50 applications and they want to know which ones won't work. And maybe the network engineers haven't set up a good test bed for them. And then you have a network engineer who might be wanting to set up these test environments, for themselves or for other people, but um, they just either don't have the software, hardware, or they're just overworked, and they just don't have time to do it, which is probably a pretty common case. So that's really kind of who we're targeting. There's when I gave this talk at Aaron, there was someone that approached me about looking at testing CPE equipment, like ISP CPE equipment, for consumers to, in figuring out ways to use MAP-T. And right now it's out of scope, just partly because I have to limit how much testing, or how much we want to bite off with one, uh, not bite off more than we can chew. But also partly because the focus of this is getting IPv6 only to the end user, to the endpoint, which is really, I think, will move things along a lot better than trying to do it to like a home Wi-Fi router or something like that. So the timeline, first 6 months was purchasing an initial batch of hardware, evaluating the software. Right now we're settling on OpenWRT. We I think the reason that I ended up doing that is partially because of some of the software support um, for chipsets, and the support for things like getting the Pref64 in the router advertisement. It's a way to then try and collect applications. Right now we're a little bit behind on this, but we're going to open the collection form pretty soon here. I had to go through legal to get an agreement that would, a user agreement that would work for everybody. And then after people start using it, gather feedback from participants and summarize in a report, like, what problems were you having, what were you able to solve, and what how the device work. Is there any improvements? Is there any other test scenarios you'd like to see included? So that's that's the timeline currently, and this is due to finish up at the I want to say in October this year or something like that. But we're going to get these things, we're going to get signups and distribute these pretty soon. So if this sounds like something you're interested in, there's a couple ways you can participate. There's you contact me directly, email me. I'm on Internet2 Slack if you happen to be on there. I'm on other Slacks as well. If you DM me, I'll do my best to respond. There's an IPv6 pod website that we have set up. The idea is that when we build this, it can be, I wanted to build this separate than, I wanted to build this, Internet2 is hosting this, but I wanted to build this so the project could live on its own. So if Internet2 doesn't have time to maintain the project, that someone could go and take it and run on their own. Any source code that we develop for this, we're going to release. There's nothing proprietary to it. There's nothing that's that differentiates us about it. We want, the idea is to get as many people using IPv6 as possible. So we're not going to hoard that. And then finally, we'll have an announcement mailing list. If you want to sign up there, you totally can. It's when we start to do signups, if we get additional rounds of hardware, we're basically going to buy as much hardware as we can and distribute it. Is the goal anyway. So and with that's kind of the project and what I'm hoping to accomplish with it. So if there's any questions, I welcome people to ask it.
All right. Well, thank you for going through all of that. I'm going to give people the ability to unmute themselves. So if anybody does want to raise your hand or ask a question, certainly do so. While we're waiting for that, looks like we only had one useful comment and one snide comment, which is what I'd expect from Michael and Nick. I guess my question is, once you have this hardware purchased and distributed, who is really the best audience that you hope to get this out to? Are you looking to have this be deployed all across the world, sort of on commercial networks and R&E networks,
Right.
governmental entities? I mean, is there really any limit about
So
who could and should be running?
so per the Aaron grant, it has to like the target audience is in the Aaron customer base. So it would be, and per Internet2, it's a lot easier if we keep it inside North America. Um, we're not restricting it specifically to R&E. If there's a commercial person that wants to apply for this, we're probably going to bias towards R&E. If we get applicants, we're going to prefer them to an extent. If there's government, we're totally willing to do this, as long, the big caveat here is don't put this in a network. Don't, like, it needs an internet connection to work. It needs an upstream, and don't put this in a network that you're not allowed to put it in. As long as that's fine, like government, individual, if you're an open source developer, that's probably a bonus. You want to get some software you want to do some work. Could be a grad student. It could be, anybody on this call, that wants to test things and wants to try and advance IPv6 in their own way. It could be for their organization. It could be for a public project. But as long as there's a use for it and it's advancing IPv6, then I think that's the user base that I'm looking for. But other than that, it's not going to be restricted to nonprofits or anything like that. So,
Okay. Anybody else has any questions? I see Michael unmuted.
Yeah, this is going to be kind of a pointed question. It will not be a snide comment, Jason, but it will be a somewhat pointed question. I think, in looking over some of the building blocks for building a v6 only enclave, our experience here in ESNet and doing the same thing has been, it's surprisingly easy to integrate some of these technologies into your enterprise infrastructure, even if you're just building a small enclave. Pretty much all DNS servers, for example, have support for DNS64 that can be ACL'd into a very small network, essentially. So you can just basically say, I don't need to build a second DNS server. I don't need to build an image or a container of a DNS server. I can just integrate this into pretty much my production DNS servers. In bind, it's about 4 lines of code. And I don't really need to, I can still build an enclave that way. And that's also true with a lot of the enterprise routing gear we have. A lot of that does have the ability to run service. Sometimes you need an extra license to do stuff like that, but it does often have the ability to run the NAT64 stuff. So from a perspective of getting this integrated into a way that R&E networks can continue to support it over time, what's your vision for transitioning from this little like v6 only in a box to something more carefully integrated into, I shouldn't say this is not carelessly integrated, but something more directly integrated into an R&E network's infrastructure?
well,
what would your vision be for that?
I think that one of the outputs of this project could potentially, it's not specifically written into the grant, but one of the outputs could be, here is a list of reference architectures and what might be good or bad with them. But this is not really intended to be production. This is intended to get over the hurdle where I want to try this out, and I have these pile of tools and tech that I can get working, but I got to go talk to 17 people to make it work. I have to convince them that modifying a production service is a good idea. That's the hurdle that this is intended to get over, to sort of decrease the fear of moving to this and show that it's possible, it's doable. We might have problems, but we know where they are. It's not specifically written to transition out of this. It's not intended to run your organization over this. In fact, specifically, this is for testing only, because the tunnel termination service, we have to make it a discretionary thing. Like I can't give you unlimited address space over it. It's intended to be, again, it's a small single device. It's not going to run an enterprise Wi-Fi network. It's just going to be a small test thing. So to a certain extent, it's out of scope, but I think one of the outcomes could be that, especially if someone is interested in helping author that. If, because I think there's I think that where people are, where it seems the industry's, like, at least enterprise networks or, company networks are coming to, seems to be like a really good fit to do sort of combine almost like a combination of all of these, where you set up NAT64, DNS64, and then you turn on Pref64 to make it, 464X that work, and then potentially use DHCP option 108. I haven't tried it, but it seems like if you combine those things, for the most part, it will just work, but it's just sort of ways to design a network to handle that. And, again, you can present patterns, but this is really there just to get people over their fear of it and start showing people what's possible.
Thanks.
Yep. All right. John Graham, you had your hand up next.
Yeah. We have about 300 systems on the National Research Platform. Half of them currently are IPv6 dual stack.
Mhm.
We've got a project right now to get as many sites as possible running V6, but some sites can't yet.
Mhm.
So would our use of this IPv6 container help us transition the folks that can't by maybe deploying it on the V4 and then
Probably not. And the reason I say that is, yeah, you could hook up one of those sites to these, and in fact, if you want to apply for it, more than welcome to, if you want. But this is, again, really not. I think what you're really looking for is either native V6 access or tunneled V6 access, because you're really looking at dual stack. Like,
yeah,
I think you could potentially even set up a tunnel V6 if you have a way to terminate that in a place too.
Yeah, we can tunnel to the local the regional folks that do have the V6 capabilities. We were going to do that with NicerNet, but NYU got their V6 stack going. So
yeah, and I think, again, if you want to try it and just see how it works, I'm not opposed to that. I think what this project really, I think, is targeting is trying to work on V6 only networks and seeing how it's working.
Well, that is our goal right now.
Yeah.
We're just doing the dual stack just so it can keep running.
Yeah. So I honestly think that if you wanted to try one of these and then put it in an environment that's running DNS64, NAT64, like, more than happy to. If you want to deploy it widely, this is probably not the tool for that.
Gotcha. I wasn't thinking about widely deploying it. I was just trying to use it for edge cases to maybe help them get over the hump. But yeah, IPv6 NAT is tunneling. Yeah, either way.
Yep. And to be fair, this does use tunnel. This project will use tunneling if you can't get native IPv6. And the reason why is it's an easy way it'll use WireGuard to provide to get to basically Internet2 IP address space, and we present Internet2 IP address space to you. It's it'll be a chunk of address space, probably a /56 per device. So
are there any plans to go beyond just getting IPv6 only functioning? Are you looking at multi-domain SRv6 microsid, for instance?
Probably not. So
Okay.
this is really looking at I'm open to you talking me into it, but this is really looking at um getting the world as a whole on IPv6 only network. And SRv6 is I personally see that more as a transport thing within inside an organization. Like interdomain SRv6, I don't like
There's a way.
There's a reason that you don't let people specify MPLS tags when you're running a service provider network.
You create a layer 2 network to stitch the edge data centers together. So you do SR on the edges and layer 2 across the wide area.
Yeah. Yeah. So
Not
I don't know
production.
that I don't know that's necessarily a target for this. Again, I'm open to you convincing me.
Well, we have experiments running.
If I could chime in real quick, I think there's other considerations with SRv6 that are way outside the scope of just running, SRv6. When you start talking about doing interdomain stuff, it compounds that exponentially. And having done a significant amount of IPv6 only work for the DOE for the last couple of years, that's already a pretty full bag of stuff to deal with.
Yeah.
Well, we are doing multi-domain SRv6 using Fabric, ESNet SmartNIC, and the P4 stack that's been extended to support SRv6 microsid. And we just create a layer 2 tunnel between USDSD and Starlight, and there it is, multi-domain SRv6.
Yeah, I mean it's definitely doable. I'm just saying that there's not a lot of commercial support. I mean, commercial V6 is still pretty new, so thinking about it from the perspective of supporting it long term is a consideration.
And I think going back to what this project was really like, what does that do to get people off of V4? If it's, to me, I think, like Nick said, like getting V6 only network in the first place without any SR is one thing. And I'm trying to figure out if, I think if SRv6 doesn't make a significant chunk, take a significant chunk out of going V6 only and retiring V4, then it's probably, it may not be right for this project. It's still probably a good thing to look into. It just may not be right for this project.
It's definitely another project.
Yeah. So I saw a question from Elizabeth on working with Starlink and IPv6 in remote regions. And this device requires an internet connection with at least V4 on it. It doesn't provide an internet connection. And we don't directly have a partnership with Starlink or anything like that. So but I recognize that is a very important thing, that getting network access to underserved communities is very important. So if they can get internet access and they would like to one of these test IPv6 only networks, I think it'd be worth applying. So
all right. Do we have any other questions related to the topic?
I just wanted to say thanks for doing this, and I would encourage any university folks that need to work with specifically the National Lab Complex that is working on moving towards V6 only to use this as a good springboard for learning how you can further deploy V6 into your networks. And thanks for doing this.
You're welcome. Thanks to Aaron and thanks to Internet2 for giving me the time to work on it. So yeah, I encourage people to apply even if they're not quite sure what they'll do with it. Go apply, get some free hardware, get some more tech to play around with. It's not going to hurt. So The application form will be up very soon. I am actually working with our legal to finalize the participant agreement. So thank you, everybody. Appreciate it.
Well, thanks, James. And shoot me a copy of the slides when you get a chance, and I will make sure that those get posted. We're on a 1-week break, so there will not be a talk next week. But on June 14th, we're going to be having a talk on the Icicle testbed. So I will send out some information on that. Hope everybody has a good weekend and good off week, and we'll talk to everybody soon.